Hello and welcome everyone. My name is Darshit and I'm excited to be hosting this 38th webinar in our Godrej Storage and Handling Knowledge series titled Part 2 of Innovative Construction Practices for Sustainable Warehouses. Before I move on to introduce our esteemed speaker for today, let me just revisit the core purpose of running this knowledge sharing platform that is built specifically for intralogistics domain. I would say it as a Godrej way of giving back the knowledge that we have gathered in the past 6 decades now to the society and the industry. I'm happy to say that the response to our platform has been overwhelmingly positive, and it has been a great encouragement for all of us to continue this initiative. And we are at the fourth year of this series. Talking about today's topic, warehousing plays a crucial role in the global supply chain, ensuring the smooth flow of goods from manufacturers to retailers and consumers. However, as world faces pressing environmental challenges, it is necessary for our industries like warehousing and storages to set up their efforts in adopting sustainable practices. As we delve into the second leg of topic, innovative construction practices for sustainable warehouses, we will explore how modern pre-engineered building solutions can be employed to create sustainable warehouses. These solutions not only optimize energy efficiency but also reduce material waste, leading to environmentally responsible construction practices. Today, we have the privilege of learning from an expert who have made significant contributions to the construction industry and promoting green technologies. Mr. Mohit Kapoor. Mr. Mohit Kapoor is heading the Steel and Building Solutions in APL Apollo Tubes Limited. Is a business development and marketing professional, having successfully introduced many innovative solutions of international and national brands in construction and infrastructure industry like earthquake and vibration resilient dampers and bearings, blast-proof coatings, bipolar ionization, and antimicrobial coated metal falls sealing systems. Mr. Kapoor is a core member of the Steel Promotion Group and the Korean Indian Forum on Green Hydrogen Initiative, demonstrating his involvement in cutting-edge sustainable initiatives. Moreover, he is a founder member and chairman of the Events Committee in the Warehousing Association of India, showcasing his leadership in the industry important events and developmental activities. So before I move on, and I would request everyone to put in their questions in the chat box on the top right of your screen. We shall try to answer them straight away or towards the end of the session. Please do not forget to write your name in the box above the Q&A section. That will help us to get back to you after the webinar in case we miss your question. We hope that by the end of this webinar, you will have a better understanding of innovative sustainable construction practices for warehouses. So with further ado, I request Mr. Mohit to take over and wish everyone an insightful session. Over to you, Mr. Mohit.
Namaskar, everybody. Good afternoon, and thanks for Godrej team for giving me this opportunity. And it's a very noble cause, and I believe climate change is everybody's business, as this is a very familiar and very important quote by Mr. Amitabh Kant that climate change is everybody's business. So we in construction industry or in infrastructure development industry, and many of you guests who must be into industrial sector or warehousing sector or any logistics sector, we all have our due share in contribution towards achieving a sustainable and green environment. And I'll try my level best in next 45-50 minutes that's allotted to me to explain how this particular technology of steel tubular construction can help us achieve faster constructions, greener construction, more sustainable options. So I'll just start with now. See, the topic of this presentation is Nai Soch, shift to greener, sustainable and speedy construction. The role of steel in decarbonizing India's construction sector in the face of climate change net zero 2070. See, I'll start with certain words from this particular slide. Why it is a Nai Soch? greener. As we all know, it's our responsibility to take care of our environment, because there's no point putting in our blood, sweat, time, efforts in construction, in infrastructure development, in creating something new for our future generation. But unfortunately, if our acts today are just gonna pile up their agony by environmental effects, so our efforts today will be actually detrimental to their life in future. And speedy construction, because in current modern world, when India is pushing ahead towards achieving 5 trillion economy, we need to design, plan, execute, and start operating any type of activity very fast. And another point that is highlighted here is decarbonizing India's construction sector net zero 2070. As you all, ladies and gentlemen, must be aware that Indian government has pledged to achieve the target of net zero by 2070. And with the efforts currently going on and very honest approach towards this, I believe firmly that this target can be achieved much faster. So how we do it in construction, we'll discuss in coming slides. If you look at the last phrase, a revolution in construction industry, how this technology is considered or claimed by us as a revolution in construction industry, we'll now discuss. So these are few contents that we'll be focusing on today. Parameters of a project success, tubular steel frame construction process, tubular versus conventional technologies, cost economics, benefits, state case studies, and company at a glance, which is promoting this technology. See, if you look at this slide, these four basic parameters define any project's outcome. The speed of the project, and in speed comes the planning, the preparation, execution, and the time at which a project starts rolling out revenues or starts operating its prime objective. Then the quality of construction, because there's no point in speed of anything if the quality is not maintained, because we are working upon permanent structures, we are working upon long duration business model, so it should be durable, it should be have quality checked. Then the cost, we cannot afford anything which is very fast, which is good in quality but abnormally costly. And then the environmental effect, as I said in my opening remarks, there's no point in putting our efforts in any development if it is gonna cause environmental effects. And in last 1 month, most of you must have seen first time in your life duration such drastic changes in environment, such catastrophic events in Himalayan states of Himachal Pradesh and Uttarakhand. It happens every year in this season, but I haven't seen in my life, my last 4.5 decades of my life, some similar events happening within an interval of 15 days, which shows the environmental effect that certain human activities are causing. So this tubular construction is, we believe, is a one way to get all these four parameters in line. So we have a motto of build better, build faster. This is a basic thing which we show to the people who are deep rooted into construction site. For all you esteemed guests, I'll just focus on one particular thing, which is the third one on the right side of your screen. You might be seeing a site under preparation. So this particular thing shows that this tubular construction works simultaneously while all other activities are happening at the ground. This thing also happens, that is, by this I want to say that pre-engineering building works simultaneously at yard as well, as its name suggests, pre-engineered building, and at the site itself, the site preparation is going on. This particular aspect is exactly same in case of a conventional pre-engineered building also, and our system also. The only difference is in site erection, which you can see at the last on the right side, downside, the site erection thing. Our system is 100% non-welded at site. We believe in welded at factory and bolted at site, so we don't use any type of welding, any type of cutting, any type of environmental effect acts of construction happen at the site. We do all these things in very controlled environment at the yards. And this particular use of tubes is not something new that we have innovated. These hollow structural steel tubes have always been in construction field, but their usage was limited to a very specific field. So only 10 to 15% of a construction steel was of these tubes. And there were certain myths, or I would believe non-updation about this technology, which led to very limited use of this particular technology of ours, was the unavailability of large sizes, very limited size range, very larger MOQ demanded by certain manufacturers, very high lead time and wastage. So how this particular technology of hollow structured steel tubes have eradicated these five drawbacks, we'll discuss in coming slides. So application of this technology is everywhere, right from high-rise buildings of hospitals, schools, courts, hotels, malls, offices, to infrastructure projects of railway stations, airports, up to warehouses, cold storage, factory buildings, aviation, data center, everywhere. So a steel tube can replace a conventional RCC element or a conventional, much more polluting built up section or older way of construction in any type of construction. What we achieve using this technology in comparison to a conventional RCCs, we are saving at least 16 days each slab, or if I talk in normal language, at least 16 to maybe 20 days each floor we can save in case of high rise buildings, and a similar type of time reduction we can achieve into sheds in factories which are not multi-floor. These are few basic differences between our technology, that is a steel tubular technology, and RCC construction. At least 30 to 50% less time, construction time, and as all of you know, time saved in executing a project increases our ROI, increases our IRR, increases our revenues, which is the main base of our business model. Then there are low project cost also, and how we achieve that? By using these tubes, we can achieve at least 2% additional carpet area. In certain cases, we have seen in case studies up to 4-5% extra carpet area can be achieved, which itself is a revenue model. Then the low financial costs are involved in this technology, because we show it in upcoming slides that using this technology, the contractor or the fabricator can very meticulously plan to procure or purchase only that much raw material which is in their production plans for next 15-20 days. So they don't need to purchase, invest extra in raw material, which helps in construction costs. And when we execute a project fast, our cash flow advances. And we have seen in case studies IRR increasing by up to 1.5 to maybe 2% by using this technology. And then this is very environment friendly. There is no air pollution. So during winters or in some other months, maybe in some areas, construction activities don't need to be stopped. By using this technology, the project goes on 24/7, 365 days, which is a very good benefit. We are not here wasting 20-25% of our time in NGT stoppages and bans. Then water conservation, that's a big issue. An RCC or a conventional building requires water from day one till end. And in fact, studies by IIT and certain other construction agencies have revealed a conventional RCC building keeps on utilizing or sucking water from ground level, underground levels. By using a steel model for construction, we don't require any water during construction activities after the basic foundation or basements have been done. And a steel building will comparatively not use water from underground sources or not suck the water from underground sources. So water conservation is a plus point for this technology. Then the recyclability. As we have been seeing for last more than a decade in, say, very advanced and cash rich countries like UAE, they keep on demolishing their existing structure and keep on expanding them vertically or maybe horizontally within next few years or next decades when their FARs or their technology advances, they need new buildings, they need bigger buildings. By using a steel construction, we can 100% recycle the entire steel used in the main frames. So it is sort of an FD itself. Whatever raw material you are using today for construction, after say 20-25 years, if you happen to demolish that building and go for a vertical or a horizontal expansion, you can actually, or the users and the investors of that particular building can use recycle that particular material, get a revenue out of that material. So recyclability is a big issue. Then a superior strength in steel construction helps us in better seismic and hurricane affected area designs because of the ductility. In the next few slides, I personally used to say these are certain scary slides. These are global average surface temperatures in last few decades. So you can see as temperatures are rising, environmental effects are there, global mean temperatures are rising, and India, we are the fifth largest economy right now, but unfortunately, we are the fourth largest contributor to pollution. And in current full throttle rush of infrastructure development to become third largest economy in next few years, and then maybe much higher, achieving the 5 trillion goal, our construction activities have to be doubled or tripled of what it is today. And construction industry itself causing a lot of environmental effects. It's our duty to find out innovative ways how we can reduce these environmental effects. These are global CO2 emission levels. This is a study which shows that 30% of construction, 30% of the total environmental effects or pollution is caused by construction industry. So it is one of the biggest contributors after power generation. And by using this tubular construction technology, a lot of international and Indian research have shown we can reduce the carbon emission coming out of construction by 60%. So if we go by numbers, by calculation, sorry, this particular methodology or this particular technology can reduce close to 1/5 of the total pollution cost. These are certain sustainable goals which have been taken into account by United Nations in 2017 seminar. And if you can see, sustainable cities and communities comes at number 11. Industrial innovations and infrastructure comes at number 9. So there have been a lot of debate how construction and infrastructure can also help in achieving net zero. These were the 5 promises made by India in the Glasgow summit that will reduce at least 1 billion ton of total projected carbon emission by 2030 and will achieve the net zero target by 2070. And this technology can help us achieve these targets well within the time. And certain measures that have been lined up to achieve net zero target, if you can see, we have highlighted 3 of those ways in this slide: green infrastructure, sustainable building, and efficient use of technology. This is a glimpse of our building and construction sector. Around 9% of India's GDP comes from construction sector, which in next 5 years will be in double figure. Around 50 million people are getting employment, but 40% greenhouse gases are also being contributed by construction sector. And since I said previously, cement and steel are top carbon emitting industries. So we need to find out ways how to decarbonize these industries. And by using this innovative technology, we can reduce the consumption of cement by up to 57%. So our infrastructure growth, our construction growth will not be hampered, and still we help out our government agencies to reduce carbon emissions. These are certain targets which have been highlighted by UNESCO, by Indian government, and this says even in short term as well as in long term targets that steel scrap recycling, adoption of best technology and expansion project will be key to achieve our targets. And how steel has advantages in achieving these things. As I said, India is about to invest $1.5 trillion in infrastructure in the next 10 years. So we can say a negative side of it could have been increase in carbon emission, increase in pollution. But by using certain innovative technologies like this, we can reduce those ill effects. And these steel buildings are much better in weatherproofing, so they will be sustainable. We'll have to invest less time, labor, and investment in maintaining them. Steel is recyclable, so it's a sustainable product. Carbon emissions for reuse. By reusing these recyclable, we can contribute in carbon, reduce carbon emissions. And these building using steel are much more flexible. So we can help in much lesser greenhouse gases emissions. And Indian government is putting a lot of efforts in policies and they need response from Indian industry of using new technology like this and many more other technologies which are in the market right now, which must be coming up in next few years to help achieve these targets. So as I said, there are a lot of issues, but humanity has always tried their level best to fight any of the calamity, any of the challenges that came in our way. And this climate change is everyone's business. So we, in our capacity, must try and do whatever best we can do. This is a basic flow. Whoever is from construction industry or might have worked as a project manager or a supervisor in your own in-house projects, they all know a basic how a basic pre-engineered building is made in conventional method. What we have to do is, first of all, we have to procure steel plates, then cut them, which require a lot of investment in machinery, a lot of workforce, and it increases carbon emission. Then again, they have to be welded from both sides, out of which one side is a temporary thing of just stitch method, which is due to have any effects of water leakage or rusting later on. And then again, we have to go and use a lot of machinery, a lot of labor to go for drilling, holing, and then at least 4 pieces have to be attached. So that adds on to machine use, add on to labor use, add on to energy consumption, and all welding and cutting related carbon emission and gases to make at least a 12 meter or a 9.5, 10 meters span of a section. Whereas if you see in the lower side of this slide are hollow tubes which are ready made coming from a factory. You just need to drill them once, attach these plates, and total fabrication time is reduced by 50%. Wastage is reduced by at least 7 to 8%, and use of unskilled labor, which adds on to project delays and other things, is reduced to at least 70-80%. As we have compared this tubular construction with RCC construction in previous slides, we'll give a brief comparison for conventional built-up steel sections or a conventional steel method of construction. This particular technology is 20% faster. It's easy to fabricate as we have shown in last slide. And welding a tube or a section from 4 sides is very tough manually in a factory, whereas in our system, the tube is welded from factory in an automated model, and we just have to weld it at one side and a very smaller side where we have to add base plates on the both sides. Then there's a repeat of our initial slide, lower project cost with additional carpet area and at least 10% of less consumption of steel, the project cost goes down. A steel tube is aesthetically better. We can achieve larger spans of up to 100 meters. This particular 100 meters we have mentioned because at the moment we have designed warehouses and industrial sheds up to 100-meter size only because of design preference by clients and consultants. Whereas in Air Force hangars and certain coal and material handling units in thermal power plants, we have even designed up to 129-meter wide span. So using our technology, widest of wide spans can be achieved, and we can achieve clear height up to 3%. This is a general cost comparison when we compare this tubular construction with a conventional RCC or a cement construction. If you see the bottom side, when we are designing, and I'm saying this very strategically and with responsibility, when we are on design board, when we are on design table, we are making a budget of a project, then this tubular construction may look around 200 to 250 rupees costlier than a conventional RCC. But when we take into account faster constructions, more carpet area, better and faster revenue roll up, then eventually this budget turns around. We become much more cost effective, because if we achieve at least 2% more carpet area, then this 200 or 250 rupees delta is erased the day we start manufacturing our tubes. And then by achieving a project execution much faster, we help in the time period that any contractor or any developer has to pay interest for their project development. The revenue or the sale of a project starts much early. In case of end user, their operation starts much earlier. So this delta of 200 or 250 rupees actually reverses. This tubular construction ends up being much more cost effective and beneficial to a client. These are certain case studies which we'll share with Godrej team, and anybody can ask for them. These are certain case studies of different sizes of building, different height of building, different span size of building, that how this technology has helped the contractors and the end users. This slide shows that you have to use a very small size section using this technology. At least 40% less area is covered using this technology. As you can see, for a G+12 story building, which was a case study for this project, only a 500 mm by 500 mm size column was used in comparison to a conventional steel or RCC building where a much larger size was used. So this 40% less cover area results into faster construction, more utility of the area, better movement of your material handling units, your load carrying cranes, etc. within your complexes, and much more sellable and usable carpet area, and less consumption of steel. We promote using a concrete filled tubes for load bearing capacity vertical columns. And why we use these CFT or concrete filled tubes is it reduces the site work, it reduces material waste, it improves the quality. 70% greater load bearing capacity has been tested on these carbon filled tubes, and this is not something new. It has been used in India for decades in certain strategic projects, and worldwide this is a common practice of using a normal concrete filled tubes for vertical columns, because a combined compressive strength of steel individually and concrete individually is less than the compressive strength or load bearing shear strength of a concrete filled tubes. That will be shown in upcoming slides. Project can be designed with much better seismic safety, and most of you must be aware, recently Government of India has changed the seismic map of India. 2 years back or 3 years back, zone 1 was removed, only zone 2, 3, 4, 5 were considered, and from now onwards they have increased the seismic zoning or increased the risk factor to up to zone 6. So with upcoming Indian construction going vertically high in the seismic prone zones and much more seismic activities happening due to certain geological reasons, it's better to go for a more ductile steel building for better seismic safety. And then when a steel tube which is procured from a factory environment, from an automated machine, you can have a guarantee of quality check and ease of construction. And yes, when we can reduce the use of concrete by at least 50% to up to 70% and the steel by 40 to 50%, then the construction cost or the investment in any project also drastically reduces. These are certain very technical slides which show that in a conventional steel building, you have to confine a steel column with a concrete thing. But in case when we pour concrete within a closed jacket of a steel tube, then the confinement of steel, which is basically the strength capacity or performance capacity ability of a steel, it increases multifold. If in case of the upper slide, this one where my cursor you will be seeing, this is a diagram of a conventional steel column, which is an H column and I column. The biaxial movement resistance or the capacity to bear any seismic loads, seismic activity is much more better in case of a rectangular or a square hollow tube filled with steel as compared to a conventional HI beam. And this slide proves what we have been saying of better carpet area or less coverage of carpet area. For a same load bearing capacity column, the size of a steel tube having concrete filled in is at least 50 to 60% less than to a conventional concrete thing or an old time steel building. Sorry. In case of a conventional RCC column which has rebars which have their own issues of labor, quality control, missing any point of joining them, binding them, when a concrete is poured after shuttering around it, only 40 to maximum 60% concrete achieves confined qualities. Whereas in case when a concrete is filled within a hollow tube, at least at 70 to maximum 80% steel is effectively confined. So its ability to bear load increases by at least double. And these concrete filled tubes also perform very well in case of fire. In a case of a concrete encased column or a column entirely made of a concrete, higher time limit of exposure to fire degrades the concrete. It cracks the concrete, it breaks the concrete. But in case concrete is filled inside a hollow closed tube, the mass that is filled inside helps to reduce the effect of fire on a column. And IIT Hyderabad studies, in fact, 2 studies done by professors in IIT Hyderabad, different professors have proved that a concrete filled tube, the fire retardance increases by from 15 minutes or 20 minutes of a concrete structure to up to 1.5 hours. That too without use of any costly anti-combustion, anti-incumbent or any vermiculite paints. These few slides I'll rush through very fast. These are very technical slides. These shows how a concrete filled tube, a steel tubes is depicted on this right hand side with this red line. Even if under heavy seismic or heavy load pressures, in case of a normal concrete column, it will crack. But in case of a steel encased column of filled with concrete, it will definitely have an outward buckling, but that steel jacket will hold it 100%. This is a slide which shows how a behavior of concrete filled tube increases. A collective compressive strength of steel plus tube collectively is just 1921 kilonewtons, whereas for a concrete filled tubes it is more than 2050 or 2100 kilonewtons. These are certain other slides which shows different aspects of behavior and performance of a concrete filled tubes under tension. This slide shows how they perform under the bending forces. This slide shows how these concrete filled tubes perform under torsion effects. And all these last slides, summaries on this slide, that earthquake resistance behavior or a seismic behavior, or in case of heavy torrential rains or hurricane areas near our shores, vibration and wind induced effects behavior under those effects of a concrete filled tube is much better than an RCC column or a conventional steel column. This technology has been used worldwide for decades now. These are few international projects. All international codes, including the Indian code, which is at the bottommost, IS 11384/1985, all these codes promote this technology. And as the code says, this concrete filled tube code is existence since 1985. So consultants, contractors, end users now must promote this technology for the benefit of everybody. And there have been certain myths, certain misinformation about how these steel tubes can be bolted or fitted with other hollow tubes or other steel channels. So in few slides, we'll rush through. We have already worked on a lot of case studies. We have done projects where we have worked on the connection details of every size, every shape of hollow tubes filled with concrete. And we'll share all this data with Godrej team for anybody to go in and have a third party check as well and evaluate themselves. So all these hollow tubes rather are much better for joining with other sections in comparison to an RCC column or a normal conventional column. So all these are not just research or case studies or our design work. These all are the slides or drawings from our existing executed projects and ongoing projects, which all are mostly IIT vetted or a third party checked. These are certain case studies in which it has been proved that by use of these concrete filled tubes, we can reduce the cement consumption as well as steel consumption exponentially. This data is also available for anybody to cross check and evaluate themselves. So concrete filled tubes, it helps in sustainable construction because of the minimum use of energy for fabrication, minimum use of energy for erection, because we just need normal bolted method of erecting at site, and almost negligible use of water. So this CFT is a one-stop solution for speeding up construction, getting better aesthetic, better seismic designs, as well as contributing to pollution control. And this is a summary of how it helps in fire retardants, how it helps in betterment of fire performance. This will also be shared with you along with other research data to check. Then there has always been a myth or a misconception about corrosion in steel buildings. These two slides, this slide and upcoming slide, we'll also share the data. These shows that the project they have been constructed way back in 1950s when certain steel parts were cut down in the process of vertical or horizontal expansion of the project or some aesthetically facade changes. It was found that when those pieces were cut, the inner part or the cross sections revealed there was no phenomenal exponential corrosion happened because steel corrodes, definitely corrodes, but the steel quality or the grade which is used in construction, it keeps on improving day by day because of less carbon content in that. And then a lot of protective coatings and paints have been created, innovated in recent years, which makes sure that your steel building will stay intact. It will perform perfectly without any corrosion effects, braving all weather things and stay there for as many long years as a conventional RCC building is supposed to be there. So a building designed for 30 year, 50 or 100 year, whether it is built on RCC, whether it is built on tubular sections, it will perform perfectly similarly. There are no effects of corrosion. These are certain case studies done worldwide, which shows that corrosion has negligible effect on construction steel. I will repeat my word. Corrosion has negligible effect on construction steel when proper procurement, proper fabrication, and proper painting, epoxying, painting, or any type of painting, any type of mitigation thing is taken care of properly at the time of execution. These are certain myths which were about construction using tubular construction, that the bolted construction are very difficult. But a lot of projects have proved worldwide and as well as in India that bolted connection are not just implicable as per Indian code, they are much easier to achieve, they are much easier to maintain and repair if in case any eventuality happen. Then definitely steel looks a bit costly than concrete or aggregate or sand, which is used for RCC construction, but a reduced consumption, increased carpet area, fast construction actually reduces and removes all this delta and the project becomes beneficial. Then there were unavailability of higher sizes around 10 years back, but now bigger sizes of 500 by 500, 600 by 400 and up to 1000 by 1000, 1000 by 100 are already in market. So any consultant can design for heavy load bearing structure, vertically high rise structure, very big span structure. So availability of raw material for bigger structure, load bearing structure is no more there. On-site fabrication is not required in this construction. You can go for 100% zero on-site fabrication, which we'll show in our proof of concept in upcoming slides. And these are actually architecturally more expressive by use of different shapes and different sizes of orientation of steel columns, tubes. You can make your building architecturally more pleasing. Then using these tubular structure, the wastage of steel has been reduced to as low as less than 1%, wherein conventional HI beam or built up section, the wastage of steel material is at least up to 5%. It may go up to 7, 8, 10%. Now we are coming up on our proof of concepts. These are on-site images of 6 hospitals that have been built last year in Delhi. All these hospitals are at least G plus 4 floors or ground plus 5 floors. Minimum 3 lakh square feet to up to 6 lakh square feet of the area, covered area. So these are full-fledged PWD hospitals. More than 2 million square feet area was there. More than 18,000 ton steel was used. And despite this humongous size of G plus 4-5 structure, collectively 22 lakh square feet area, collectively more than 18,000 ton of steel and 6 different locations. And all of those who are familiar with Delhi, all these were not actual greenfield project. These were all expansion and extension of existing projects in densely populated areas of Gita Colony, Sultanpuri, GTB Hospital, Shadra, Sarita Vihar, Raghuvir Nagar and Shalimar Bagh. So you can imagine the labor cost and efforts to take any construction material over there, labor over there and executing project in those dense areas. And this technology helped Delhi government to execute this project in flat 90 days. 90 days to 100 days were taken in erecting the entire structure. Currently, all the interior works and outer finish works are about to end. The work that was completed in minimum 90 to maximum 100 days at these 6 sites was the erection of the main frame or the structure. If the government would have opted for RCC structure, at least 15 to 18 months they would have taken to complete that task, which we helped them to complete in flat maximum 100 days. This is another prestigious project of Indian Army's paramilitary forces residences, which is happening near Delhi Airport in Shankar Vihar. We are about to complete the first phase of 90,000 square feet in flat 2 to 3 months. Then a lot of universities are using this technology to finish their project or go for vertical expansion and made sure that their projects are executed way before their next year's academic sessions. This is one of the most prestigious projects. In last 2-3 years, this technology was sent to IIT Roorkee, IIT Mumbai, IIT Chennai for vetting, for checking. IIT Roorkee themselves, premier most institute of civil and construction industry in India, they were so impressed with this technology that the latest project that's happening within IIT Roorkee's complex, Mittal School of Artificial Intelligence, they are using entirely this technology to make their own project. So IIT, which people look out for vetting and guarantee of their project, they themselves are using this technology. Another campus which is happening in high seismic zone Imphal, one government and one private hospital are now coming up on this project. Certain commercial complexes like this mall near upcoming mall near Bangalore airport, that's coming up on this technology. This, as you all know, Indian government is redeveloping 400 station, out of which New Delhi railway station is the biggest project. The total budget value is around 5,000 crores. They have written specifically in their tender for faster and lighter construction, steel tubes should be preferred. Because Indian government and Indian Railway realized during their planning time that we are saving 50% of the area required for columns and beams and reducing at least 30% of their construction time and 100% of any type of hardship that they might have faced if they do on-site construction using RCC or on-site construction using conventional RCC steel structure, because 16 platforms, they operate 24 hours, 365 days in Delhi. Million of people travel there. A lot of rush over there. So it was not possible for them to go for conventional construction. They have specifically opted for this technology. Then this Tirupati railway station is already using our technology down south. A high-rise housing project in Mumbai, the tender is in market. They are using this technology. And these are certain case studies of industrial and warehousing sheds. In this particular set, this is near Ghaziabad, I believe. For a 40,000 square feet, 20% steel was saved. We can share this case studies for anybody, and anybody can also visit this site. This was a very good project in Delhi. Before giving this 6 hospital project, Delhi government gave this 15,000 square feet oxygen plant near Narela for checking this technology's quality, actual cost in the project execution and time. This technology helped Delhi government to finish this project in flat 15 days. So just imagine 15,000 square feet plant in flat 15 days, in which last 3 days were consumed by agency for doing the roofing and the sheeting part. The main frame was executed in flat 12 days after the foundation work. This is a huge industrial shed in Raipur, Chhattisgarh, wherein this technology helped this client finish this 3.5 lakh square feet project in 8 months. This is a sort of a closing remark on how this technology helps with conventional built up steel by 20% faster completion, lower lead times, higher capacity of producing these tubes, ease in fabrication, lower project cost, aesthetically better, larger spans, and extra clear height. When we talk about larger span, recently we received few orders in places called Hoskote and Malur near Bengaluru. The original design suggested by conventional steel contractors to the client was to having 20 to 25-meter span for their project. We helped them achieve 35 to 50-meter of span, which reduced entire rows of columns, which helped them achieve faster execution, less cost, and more usability of their area, better movement of their material handling units. And as you all know, in case of warehouses or industry, the cost is calculated on area which is used for pelleting or the area which is used for stacking product. So a 10% or 5% extra area helps an end user in getting more lease or storing more products. There could be a very genuine question that with so many benefits, why there are less steel buildings in India? The reasons have been highly cost sensitive market, but we have shown it in our slides. We have proved in a lot of projects that we or this tubular construction may look high in cost when we are planning, But when we achieve better carpet area, when we execute a project fast, when we do aesthetically better buildings, when we do projects which require less maintenance, less repairs in future, then actually we are benefiting in cost. Then the project deadlines hardly matter in India. So for a project where client needs a specific time frame, or a project is of a strategic of a national interest, this is a technology to go about. And RCC construction generally employs unskilled, semi-skilled labor, which unfortunately for next at least 5 to 10 years, India will have this problem of unskilled labor force, which adds on to delays in project, which adds on to certain accidents in project, which add on to complexity in the project execution. Whereas in case of steel construction, highly skilled labor is used in factory to fabricate tubes. Very highly skilled labor or semi-skilled trained labor is used for fabrication and erection. So these accidents, these delays, all these losses are all mitigated very easily. India is the second largest producer of cement. So for obvious reasons, when cement is in abundance, people are going for cement construction. But even those cement plants have their capacities, and with upcoming upsurge in construction of bridges, construction of highways, construction of roads in Himalayas and expressway across India, a substantial chunk of cement produced have to go over there. So this steel tube can take care of infrastructure of buildings going on smoothly without any delays of availability of cement, in addition to whatever benefits we have tried to prove you of using more of steel in buildings as compared to cement. Then there were non-availability of larger sizes, but as I told, right now we are producing one of the largest sizes. Those are available worldwide. Only 3 or 4 companies in the world manufacture 500 by 500 size or 600 by 400 size, which is now available in India. Only 2 companies will be producing 1000 meter by 1000 size when we start producing that by the year end. And there was lack of high grade steel in India. But currently, up to 450 grade of steel plates are available for making these tubes, because we are sending those tubes of 450 grade in Nanavati Hospital in Mumbai, which is under construction right now at Juhu. Max is now the owner of that brand. And in coming years, primary steel producers are targeting making 500 to up to 600 MPa quality of steel tubes, steel plates for manufacturing of tubes. So best quality of steel grade is available. So we can go vertically to whatever height we need. We can do whatever large spans. We can design our building for better seismic performance and for longest duration of life. And not all contractors prefer in expertising into their quality engineering and workmanship, which has to be left behind. All the contractors, all the designers must incorporate best practices in the worldwide if we have to match internationally for infrastructure development. So thanks, ladies and gentlemen, for this time. And now the session, I believe, should be open for any queries.
Yes, sir. Thank you for such an insightful session, sir. I could see that the nectar you have uh, the 4 decades of experience that you had mentioned. We got the nectar today. मतलब उसका पूरा juice निकाल के आपने हमको you have enlightened us. Okay, and the innovative practices that you have used, wherein you have combined the steel tube with the RCC, that has, removed all the flaws that we have in RCC as well as in tube, and you have combined it and made it
I
strong.
would like to add, Darshit, I would like to add one point. We should not use any word. Sorry for this remark of flaws in RCC. See, I would say very humbly that we cannot leave RCC totally behind. We cannot leave cement totally behind. The best thing about technology is not fashion which gets outdated. Technology is something which gets updated every day. It gets upgraded every day. So we have been using RCC. Even we use some part of RCC in filling our vertical columns to reduce the size. It's not that we need it. We could use, for example, if we need a 500 by 500 size hollow tube, we can reduce this to 350 by 350, reducing the size of area covered, reducing the quantity of steel by adding cement into it. So cement itself is also a very important thing. After all, it is the largest man-made material which is available on earth. So we are just upgrading it, innovating it to use it more effectively. Please continue.
Very rightly, sir. Yes, sir. So the questions are pouring in. We'll take a few. Yes. So I'll start with the first question. So given the diverse environmental conditions in India, how does the choice of tubular steel materials align with the requirements for durability and long-term performance in particularly warehouse constructions?
What I believe from this question is various climatic or environmental conditions. See, if we talk about geographical conditions, so steel tubes are available worldwide across India, I would say, in this matter. And right now we are doing certain projects or helping certain projects of Central Warehousing Corporation, which unlike private warehouse developers, they have to choose very remote areas. Like last year, we helped them construct a project in Kargil. Right now, we are helping certain private builders make cold storage and warehouses in Dras as well. So rather using a tubular construction, which is sort of a plug and play system, you can fabricate it in yard or fabricate it in much workable area, and you just have to transport the material in parts and parcel and pieces to the site and just assemble it. So the geographical location area is, I believe, no point here. As far as climatic thing is concerned, a hollow tube performs better than an RCC in fire. It performs better than RCC in seismic. It performs better in RCC in heavy wind load, because we have designed for 55 to 60 meter per second wind loads, as well as they perform drastically well, phenomenally well, as compared to conventional steel angles or HI beams, which are open from two end, and they are more likely to get water leakage issue due to manual welding or get rusting. Wherein when these tubes are totally covered, they don't have any effect of weather issues.
Great, got it, sir. So the second question is, given your expertise in Indian market, could you highlight any regulatory or certification standard that construction projects using tubular steel need to adhere to in order to ensure safety and quality? The certifications they're asking.
The first thing is IS 2062 is the code that defines the quality of raw material that has to be used for any steel construction, whether it is conventional HI beam steel or our innovative tubular steel. We all have to procure steel that conforms to IS 2062 standards. Further, when we are this is the what do you say, a codal part of the raw material. And then when we talk about the designing part, then there are two codes, 800, 801, 806. These three codes govern the design of any building in steel, and these three codes imply for different elements of any steel building. So, and you must remember, in one of my slides, I have shown IS 11895 1985, 11384 1985, which is an, say now almost more than 30-year-old, more than around 40-year-old code, which is governing a concrete fill tubes. So there are codal provisions for procurement of steel, that is for manufacturing of primary steel. Then there are codal provisions for welding, cutting, bending, and fabrication of steel and designing of steel.
Great. Okay. So looking at the time, I'll take last two questions, sir. So the next one is, are there any specific coating or treatment methods used for tubular steel used in cold storage warehouse construction that are tailored to unique environmental conditions of different regions in India? I mean, they are specifically talking about cold storage warehouses. So they are asking whether do they have to have a special coating for the steel tubes that are being
You
used
are-
in construction? Yeah.
See, if I just leave for a second cold storage apart, for
Hmm.
any steel warehouse or steel shed, we need
Okay.
basically three types of protective coatings. One is weather
Okay.
coating
Hmm.
to reduce or eradicate any corrosion. Second would be a fire coating.
Okay.
Third would be a coating against any chemical or any hazardous substance which may be stored within this complex.
Okay.
If we talk about cold storage, so we can add one dimension into this protective requirement. Would be a cold storage is bound to have obviously refrigeration and humidity inside or
Yes.
water content inside. So we
Hmm.
have to take care that the columns that are exposed to
Ma-
inside environment of a cold storage, they are duly protected. So there are n number of protective coatings of epoxy coatings for weatherproofing, epoxy coating for any type of chemical substance coating or moisture proofing, and a lot of coating for fire retardants also in term of vermiculite paint, which is sort of a cement slurry based paint system, and intumescent paint, which are as thin as 2 to 3 size, which are used and can be used in specific cases where you need higher fire retardants. Though we have tried to show through IIT Hyderabad study that in
hmm.
normal cases where we are not going for 11, 12 floor high hospitals or strategic building where fire retardant need to be very strict. So in case of a warehouse, you may also not require any intumescent paint as per codal provision, even
Okay.
if you need any fire paint in addition to weatherproofing or epoxy coating. There are a lot of paints and epoxy coating available in market. It depends on
Okay.
your usage and the problem that you need to solve.
Correct. As per the temperature and environment.
Yes.
Great. Great. So, before I move to next and last question, I request everyone to fill in the feedback form and help us to improve on the topics that we come for and the programs we do for you all. Thank you. So, so the last question is out of curiosity, sir, that as the country or the many part of the country is used to RCC constructions and they have seen it as a proven technology. Okay, while you were starting with the tube constructions or you're promoting tube constructions, were there any inhibitions from the client or the user that whether this would sustain, means what would happen, means uh, any resistance? I'm just talking
See,
about the mindset
yeah, I'll
that
tell you.
you
See,
must have come across. Yeah.
yeah, I'll again refer to my previous comment of difference
Ah,
between fashion getting outdated and technology getting
outdated.
upgraded.
Yes.
See, any fashion that comes, no matter how bad it look or how uncommon it looks, people tends to embrace it very fast. Wherein there
Yes.
are certain natural resistance against any technology, and we definitely also faced in last 2.5 years. But
Hmm.
I very specifically humbly use the word natural resistance. They were resistance of who should be the first person to try. Nobody wants to
Correct.
be a guinea pig.
Hmm.
Then will it sustain or not? See, any technology and more so in construction, it needs first an idea, then a national international reference, or
Hmm.
used in some other aspect, other segment, and then evolving it into some other segment like we have done it in construction. Then thorough research, trials, testings, execution, and then critical analysis. All that phase we have already passed. That's the reason why anybody in our esteemed guest will realize and accept, acknowledge that a hospital is the most critical
Lit-
and most important infrastructure building in any
In
community.
any
So
community and any given setup. Correct.
if in now, right now, in national capital territory that is in earthquake zone 6 now, as per new
Hmm.
code,
Hmm.
with very poor soil condition due to groundwater extraction,
Yes.
government hospital is being chosen to be built on this technology. In Imphal, high seismic zone, one government and one private hospital is being chosen on this technology. And now we come to private part, Max Hospitals number one brand.
Correct.
Nanavati Hospital, India's leading brand in Mumbai. They are using it for their private hospital, that too, which is going -3 basement plus 11 story height. Another Indian Army Hospital in Lucknow, which is going -2 basement plus 8 height, and then two helipads above for
Oh,
calamities. They are using this technology, which proves its worth, its strength, its technology. And another resistance that came from vendors. We as
oh,
clients or end users in anything, whether we go to purchase a our wardrobe, whether we go to purchase electronic or whether we go to hire somebody, most of us are not expert of those field. So
influence.
we tend to get influenced by our advisors, our consultants, or I would say the vendors.
Yes.
They start putting up things in our mind. So I can very well believe around 20 years back when pre-engineered buildings were introduced in India,
Mm.
there was a similar resistance to use pre-engineered building because they thought on-site or in-site trade will be demolished. Then they have to
Yes.
invest in new machinery. Same thing is happening here, but in a reverse method, because now the contractors or vendors are feeling that their investment of crores and billions in their factory for conventional steel buildings, they will be of no use when they have to use these easy to fabricate, all already welded, already cut size tubes coming from factories. So they are having this issue of considering that their machine will be of waste now. It will not be used much now.
Correct.
That's a natural resistance. But I can name 2 to 3 contractors who are Delhi NCR based, who are working big time. They have realized due to client pressure, due to
Mm.
consultant pressure, when they opted for this technology, that their, and this is a very valid point, but that I'm going to tell in next 4 lines, their fixed expenditures are already monthly basis. Their rents,
Yes.
their interest, their EMI, their salaries are all fixed. In that time frame, they were able to complete 3 projects using conventional steel technology of cutting, joining, welding, blah blah blah. They were able to finish at least 4 to up to 5 projects. So their output increased using this easy to fabricate, and their cost of construction reduced by procuring less amount of raw material
Raw
for
material.
time being.
Yes.
They don't have to produce all the raw material, more raw material at a time, because wastage was less. So considering all these things, top and 2 to 3 top end fabricators or vendors have now started using this technology and started recommending this technology. So yes, we were in a phase of natural resistance. We have cleared that. Now government is giving us project from railway to airport, from hospital to warehousing. Privates are giving us project from housing to malls to railway to accommodation to commercial complex. So we have passed that era.
Fantastic, fantastic, sir. Nicely explained. So, and I once again thank you for this wonderful session, sir, and all of our attendees. And with this, I take your bid. Thank you. Thank you, sir.
Thank you
Thank you
very
so
much.
much. Thank you so
Thank
much
you
for your
everybody.
time, sir. Yeah,
Thank
thank
you.
you.